Okay, today I'm going to discuss the types of sources. Actually, what is meant by source? Source is nothing but which is going to deliver the energy, like active elements. Suppose if sun is there, sun is the delivering element only, light energy is it is delivering. And what about the sources here in electrical? Actually, the electrical sources are voltage and current only, no? So those are the delivering the energy to the loads. Okay. So based on that, you're having different types of sources, that is independent and dependent sources. Okay. It is classified into two sources, that is independent and dependent sources. Here, independent sources again further classified into two types, that is voltage source. Okay, that is voltage source, and another one is current source. Okay, independent source. What is independent? What is dependent? I will tell you. Okay, so this is just I'm giving the classification here. I will go with everything. Okay, here in the dependent, here in independent, it is classified into two, that is voltage source and current source. That is in again this voltage source is classified into two. One is ideal voltage and practical voltage source, whereas coming to the current source also it is ideal current source and practical current source. Total 1, 2, 3 and 4. Okay, in the independent sources it is classified into 4, whereas in the dependent sources also it is classified into 4, that is VDVS, voltage dependent voltage source. Okay, voltage dependent voltage source. VDCS, voltage dependent current source. CDVS, current dependent voltage source. CDCS, current dependent current source. This is 1, 2, 3, 4. Okay, total how many sources are there? Total it is 8 sources are there. In independent sources it is 4, and in independent sources also it is 4. In independent, what are the sources? Ideal voltage source, practical voltage source, ideal current source, practical current source. Independent, voltage dependent current source, current dependent voltage source, and current dependent current source. We will see one by one. Okay, we will see one by one. So this is finished, I think, everyone. Classification part.
Yes, sir.
Okay, we will see one by one. Now, ideal voltage source I am considering here. Okay, ideal voltage source. Okay, ideal. What is meant by ideal? Name ideal is nothing but ideal means which
Single
has no loss. Okay,
countering.
which has no loss. Okay, ideal means perfect. Actually, the meaning is perfect. Perfect means 100%. Whatever the value is there, it is going to the same output we are going to get. Suppose input is 100 means output will be also 100. Okay, no loss. 100% ideal. Okay, ideal, no losses. 100% in the sense no losses. No loss in the sense no voltage drops. So voltage source here we are dealing with the DC circuits. No, the unit is DC circuits means DC, the symbol, what is the for DC we generally represent plus and minus. Okay, the bigger one is the plus and the smaller one is the minus. Okay, this is ideal voltage source. Supply, just like a battery. Okay, V suffix S, supply voltage. Okay, Vs is the supply voltage. Here what I am doing, this is the circuit symbol. We will see one by one. This is the circuit symbol. The second one is the symbol. Second one is the circuit means what? Already I said that circuit means it consisting of at least one closed path. Okay, circuit means consisting one at least closed path. Is a closed path is there or not here? Closed path is existing. Closed path is nothing but loop. That means current flowing from higher potential to lower potential. Let maybe let the load may be anyone. Okay, so let the load may be anyone here. Here I am, what I am giving, this is source voltage. Vs is the source voltage and VL is the voltage drop across the load. So here just assume that if it is a some bulb, let us assume it is a bulb. Okay, I am, what I am giving, I am giving the voltage to the bulb. What happens, this total, suppose if it is 100 volts is given, suppose if I have given 100 volts, and what about the drop here, what are these elements? No, these are the inductive element, or okay, this 100 volts will be utilized here. Whatever the voltage I have applied, that 100 volts will be utilized by the load. Okay, now what I am doing is I am writing the graphs. Okay, VI characteristics voltage. Okay, VI characteristics for the given circuit. Here current, because of the because of the source, what happens, current will be flowing in the circuit. Okay, it will circulate here. Whatever the current is there, that current is, I am representing it flowing through load. No, it is IL. Okay, IL is like this. IL I have considered on x axis. I have considered on x axis, and this source voltage is on, this is a source voltage, it is on y axis. So what is the load voltage? Suppose if it is 100, I am redrawing the graph. This is load current and this is source. Okay, suppose if it is 100, what about the, as keep on load changes, suppose the load, suppose the bulb is actually glowing with some okay, and it is in flickering mode. Okay, that may current may change, but the thing is the voltage consumed by the load will be same, because in ideal there is no loss. If it is no loss means, at any load, suppose if it is 0, okay, 1 2 3, when it is switched on, you are getting some 100 volts. When the load is changing also, you are getting the same graph. Okay, constant magnitude is there. So this is the graph, that means this is, this point is Vs, whereas this value, this whatever the value, value I got is VL. Okay, this is the graph for VL. So we can say that Vs is equal to, Vs is equal to VL, which is always maintaining the source voltage. Suppose here it is 100, here also 100, here also 100, here also 100, here also 100 volts. Okay, that is the ideal voltage source. Now coming to ideal current source. Is it clear all of you? Ideal means total 100%, if I give the same 100% will deliver to the load. Similarly, ideal current source is there. That ideal current source is also same likewise only. Just I am replacing the voltage source by current source. Generally, voltage source is represented by plus and plus and
And
minus,
minus.
plus and minus. But the current source, see the current source diagram, it is represented by, okay, it is represented in a circle.
Paramount.
In that circle, it is indicated with arrow mark. Okay, it is indicated with arrow
Paramount.
mark. Okay,
Yes.
arrow mark, if it is indicated with arrow mark, it is a current source. If it is indicated with arrow mark means it is a current source. So this is the circuit symbol for ideal current source. Now what I am doing, I'm making as a circuit means what, closed path should be there. First in the symbol it is that there is open circuit. Now what I am doing, I am connecting one load like bulb, fan or any other thing. If I connect a bulb or fan or sub any load it is, I have connected to the current source. This is the current source, that means load is connected to the circuit symbol here. So I have connected. What happens? Current will be flowing or not? Current will be flowing. Okay, current will be flowing. And here, is there any current divides? Do you have any other path? Only single path is there, no? Single path is there. Okay, you are
I
having
see.
single path. You're not having any extra path. So that's
Path.
why, okay, that's why whatever the current is there, for the load I am taking, I am considering, even it is going into the load, I am considering current as I suffix L. And this source current S is nothing but source current, that is I suffix S. So I am taking the graph here. It is here, this graph is V suffix L, which is on x-axis, and this graph is IS, which is source current, okay, which is source current, and this graph points I have plotted here, no, that is load, I suffix L. And the thing is the current is changing, ma? Do you have any other path? Will current dividing? So there is no
No, sir.
division
No,
of
sir.
current, only current. Okay, only one single path, one route is there. In that route only current will be flowing. So there is no division of current. That's why, irrespective of the load, always whatever the source current is there, the same current will be flowing into the load. Suppose 10 amps is there, means through the load 10 amps current will be flowing into it. Okay, that is why the graph is like that. Now we will go into the practical voltage source. Okay, shall I erase this all? Finished?
Yes, sir.
Okay. Now coming to practical voltage source. Okay. Right. Okay. Let us go to practical voltage source. So do you does really exist voltage source without resistance? Every wire, every copper wire will have some resistance. Every human body is also having some resistance. Yes, an opposing nature will be there, no? So normal for any copper wire also having some resistance. That is why for this voltage source also it is having some internal resistance, because it is a wire, means existing of some resistance, that is RSE. So ideally it is possible, but practically it is not possible. So that's why whatever the symbol, previous symbol, just I have taken only plus and minus I have considered, no? Previous ideal voltage source I have considered only plus and minus, but for coming to the practical voltage source, extra thing I have taken. What is the extra thing I have taken? Every wire consisting of
Resistance.
some resistance. That resistor symbol I am representing here. Okay, this
Yes, sir.
is the ID. This is the circuit symbol for practical.
Voltage
Okay,
source.
practical voltage. This is R. Its value is RSE, R suffix SE, series resistance. Here this is the V suffix S, voltage source, and this is the resistance. See here, now what happens is, this is the this is the symbol. When I connect one load to it, when I connect one load to it, you can see that here load is nothing but consisting of resistance only. Ne? Okay, this is the load. I am connecting one load. Load is nothing but resistive drop or inductive or like that only. No, I suppose if it is R suffix L, load is RL. Okay, this is load is RL. What happens here at this RL? Do you get the same voltage VS? Do you get the same voltage VS or VL? You will not going to get the same voltage.
Same.
Okay,
Yes, sir.
you are not
No,
going to
sir.
voltage, because there is some drop. Suppose this Vs is 100. Suppose this Vs is 100. If Vs is 100, here due to the internal resistance, there may be some voltage drop of 1 volt here. Okay, due to that wire there may be some voltage drop. Okay, we are assuming that there may be some value of 1 volt. So what will be the voltage consumed by the load? Voltage consumed by the load, I have considering that we know that in a case KVL, Kirchhoff's voltage law, sum of all voltages in a closed circuit is zero. And what about these two are drops, or drops only, no? Load only, no?
Yes, sir.
Passive elements means voltage drops taking place. So
Voltage
here
drop.
this is voltage Vs is the voltage rise, and voltage rise is indicated with plus, and voltage drop indicated with minus 1 volt, and voltage drop here it is plus V suffix L is equal to sum of all voltages in a closed circuit is zero. What is VL now? What is VL? sorry, this VL is minus only, no, drop only, no, this VL means minus VL. So minus VL is equal to minus 100 minus 1 is 100 minus 1 is 99. Okay,
99.
minus 99, minus
Minus
99 we will
99
get,
only.
that is minus minus get
Minus
cancel, we will
minus
get
cancel.
plus. Okay, we will get
VL is
99
equals
volts.
to 99.
99, so 99 volts we are going to get at this load. Suppose if I give 100 volts here, the 1 volt drop will be at resistor. And see that this is the graph, actually this is V. Okay, let me erase first all. Up to here it is okay. See here, you just take
Yes, sir.
not this diagram, you just take straight line. Actually it is, this is Vs. Okay, this is Vs, source voltage Vs, and slight change will be there. This Vs is 100 volts, and this VL, this is VL graph. Okay, and this VL is what, how much it is, 99 volts. 99, that's why the graph is, there is a drop of 1 volt, that's why there is a deviation here. And this is the IL. Okay, and this value is Vs, and this drop is there, no, that is the VL. Is it clear all of you? Voltage source, hello, I think
Yes,
it
sir.
is
Clear,
clear.
sir.
Okay,
Yes, sir.
now
Yes, sir.
let us go with the practical current source. Okay, practical ideal voltage source, it is consisting of that one. That means in voltage source, where it will divide, voltage divides in series only, no, voltage divides in series. What about current? Will current divides in series? Will current divide in series?
No, sir.
In series,
No, sir.
okay, in
Parallel.
series only voltage divides in, whereas current divides in parallel only, no,
Parallel.
in parallel branch only, no. So
Parallel.
practically we cannot
Yes, sir.
create the 100% current source, no. So there is some resistor, that means there is some drop here. So that's why the resistor, whatever the resistor is there, it is made parallel to the, it is made parallel to the current source. Current source is represented by, previously current source I have taken arrow mark only, no, up to here only I have taken. But the thing here, the extra practical current source, what is the extra element I am getting? I am getting the resistor here, previous
Resistance.
extra
Yes, sir.
previous volt. Okay, okay, for voltage source I got the resistor in series, because in series only KVL divides, whereas in parallel practical current source, it is divides in parallel. Okay, one resistor I have taken here. This is the RSH, R suffix sh, that is shunt resistance. Here previously for voltage source, R suffix se, series resistance. This is shunt resistance. Okay, what about circuit? Now I am taking the circuit here. I have connected one load here. Because of load, there will be current flowing in the load branch, and in the shunt branch, what this is the current, no? Suppose I current is flowing. This is I. Suppose I is flowing. What about this I? I will redraw again. You can check all of you. You can see the diagram. It is not neat, but okay, you just follow. Suppose this is 10 amperes, ma. Okay, suppose this is 10 amperes, and this is RSH, and this is RL. Okay, and what about this? We know that sum of currents entering towards the node is equal to sum of currents leaving the node. Okay, at this node what happens, this 10 amperes is coming towards this node, no, this is the direction arrow mark is towards the node. And what about this, you're getting two paths. So you can see that when you are riding a bike, you are having that, when you reach here, you are having two positions, no, you can go either this way or this way. But here what happens is, for the current, what happens is just like water. Okay, just like water, you are having two pipes, you are having two pipes, one is larger pipe, one is smaller pipe. Okay, so you can see that larger pipe and smaller pipe, what happens, always current flows through low resistance path. Okay, that is smaller pipe only. Through larger pipe, the water, whatever the water is there, it will be very less. Okay, likewise current analysis also you can do. Here this is the current. Suppose through this shunt branch 1 ampere of current is flowing. 1 ampere of current is flowing if you assume. Okay, through that shunt branch 1 ampere of current is flowing through that. What about this load IL? We know that just apply KCL. Apply KCL to it. When you apply KCL, what is KCL? Sum of currents entering towards the
I
node is equal to sum of currents leaving the node. So what is entering towards the
Leaving
node?
the node.
Entering is current I, that is 10 amperes, and sum of currents leaving, sum is there, no? Sum means what? You have to add. This is the RSH. RSH, through RSH means the current is, we can write
1
that
ampere.
as ISH. Current path I am writing I suffix
ISH.
SH, ISH. And through the load current is flowing, no? That is I suffix
L.
L, ISH plus IL. So here what is I? What is I? 10. What is ISH?
10.
1 ampere.
1
What is IL?
1.
plus 9.
1. X is 9, not 1.
9.
Okay.
9.
So through the load, ISH we assumed that it is 1, no? So through the load, the remaining current will be flowing. That is 9 amperes of current will be flowing through the, okay, 9 amperes of current will be flowing through the load. So that's why the graph is like this. Is it clear, all of you?
Yes.
Practical voltage source and practical current source finished.
Sir.
Okay. Now we will see the dependent sources. Okay, dependent sources are there. So so we have finished with independent. Independent means what's not depending upon previous values. Whereas these dependent, that means whereas these dependent sources, just like you people are depending upon father and mother, no? So likewise, just like these dependent sources will depend upon previous values, previous voltages or previous currents. Okay, either voltage or current. So likewise, here it is depending upon two sources. What are the two sources you are having? Either voltage source or current source. And the
Current.
thing is, and these dependent sources are generally represented in diamond shape. Okay, if they are represented in diamond shape, you have to assume that these are dependent sources. If it is not mentioned in diamond, if it is mentioned in circle or plus and minus symbol, directly general symbol that lines, it is called as independent sources.
Independent
Okay,
source.
so this is the diagram. You can see that is diamond shape. So rhombus, diamond is shape means nothing but rhombus shape. Okay, this is the indication. And what is the source here? What is the source here? Tell me. First one, voltage dependent voltage source. No, what is source here?
Voltage source.
Okay, voltage source. Voltage
Yes, sir.
source means in the rhombus, what you have to indicate? Voltage ఎలా
Plus
indicate
minus.
చేయాలని చెప్పాను? How you have to indicate? Voltage you have to
Potential.
indicate with plus and minus.
Plus and minus.
Suppose current
Plus
source
and
is there.
Plus or minus.
Current source is there. Indicated with
Current source.
current source
mark.
means
Arrow mark.
arrow mark. Okay,
Arrow.
nice.
Arrow
Okay,
mark.
so here voltage source is there means voltage V is equal to, current source is there means current I is equal to. Okay, and what it is depending here? It is depending upon voltage. Okay, that
Voltage.
is V1. That previous V1 how much we don't know. Suppose voltage dependent means, suppose it is depending upon previous voltage. Suppose previous voltage is 5 volts and present voltage is 5. The voltage, present voltage is V and previous value is 5. That means 5 times of V. So we don't know how much actually it is depending. That's why I am representing by K. Okay. So it is depending upon some value that is depended by K times of previous voltage V1. Okay. For always when it is dependent, you just multiply with K. Okay. You just multiply with K and you see that for dependent before value, whatever the value is there, you write down that one. It is depending upon what? Second one is depending upon voltage, second V1. Here also it is depending upon voltage, that is V1, KV1, KV1. But the source here, what is the source in first case? Voltage source. In the second case, current source. Current source means you
Current.
indicate with arrow mark. Okay. Now we will see third one and fourth one. What is third one? What is third one? Tell me.
Voltage source.
Current
Current
dependent on
voltage
voltage
Current
source.
dependent
dependent
voltage
current
source.
source.
Voltage source.
Okay. So
Voltage
voltage source, no?
source.
Voltage source means indicated with what?
Plus minus.
Diamond shape. Plus and minus. Very nice.
Plus
Indicated with
Plus and minus.
plus and minus. Here, what is the source here? Current source
Arrow mark.
Current source.
indicated with
Current source is arrow mark.
Arrow mark.
nice arrow mark. Okay. Here plus and minus is there. That means plus and minus means by default you have to write V. Here arrow mark is there. By default you have to write I. Okay. And here the first case it is depending upon current. That is why multiplied with K is multiplied with current. Here in this fourth one, here it is depending upon current only. That is K into I1. Likewise, you need to write. Is it clear, all of you? 5 minutes
Yes,
is there. We
sir.
will do one dependent voltage source example. Up to here, it is clear, I think. We will do one numerical on this. Please unmute yourself. Okay, we will go with the circuit. Okay, here we need to find the values of I1 and I2 in this numerical. We need to find the values of I1 and I2. How we will find I1 and I2? Here I am having, what are the having? I am having two current sources. One current source is independent current source and another current source is dependent current source. You can see that one is in circle, another was in diamond. You can observe that 5 amps is there, just 5 amps is there. Whereas for dependent source, you can see that dependent source, no, current dependent or voltage dependent. Here in the question, it is current dependent or voltage dependent.
Current.
Anyone?
Current.
Current dependent. Okay, because it is K times of I. K times of I is nothing but K is what? 4 times. K is 4 times and I is
4
I2.
times of.
Okay?
Yes, sir.
4 times of I2. This is the circuit, and see that here 4 currents are there in each branch. Okay, one current is 5 amps is entering towards the node and I2 is leaving. You can see that current directions, all of you just see direction of currents. Here this is upwards and this is upwards. Okay, and remaining two currents are
Downwards.
downwards. Okay, you just apply KCL. You know KCL, sum of currents entering towards the node is equal to sum of currents leaving the node. Here, what are the nodes you are having? How many
Leaving
nodes
the
are there?
node.
This is the node here. This is one node, and this is also one node. If you are having any resistors here, it is not going to be a node. Okay, here node means two or more branches meeting together. Okay, two or more. This branch, 5 amps branch, and this one. Okay, this is a common. No resistors are there. That's why I am considering this as one node only. Okay, so this 5 amps is entering towards the node, and this 4i2 is also entering towards the node. Summation only you have to do, no. So that's why
Entering towards the node.
okay, that's
Yes,
why
sir.
when you apply KCL, it is 5 is
5
plus
plus 4i2.
towards and 4i2 is also 4i2. This is currents towards the node, and this I2 and I1 is there, no.
No.
I1 and I2 are leaving the node. That's why I'm writing outside. Okay, or otherwise if you want to write in one
Outside and
expression,
this one.
you can
Okay,
write
sir.
that entering currents you can write it with a plus, leaving currents you can indicate with minus. Suppose you want to make easy, you can write entering currents are the ones LHS side, leaving currents as RHS side. Okay, up to here. Okay, 5 plus 4i2 is equal to I1 plus I2. Okay, you just don't write this one. I will tell you where to write here. Okay, afterwards, is there any chance? Mr. 516, please unmute yourself. 516. Okay, 3i2, 4i2 minus 4i2. This is 4i2 and plus i2. If I shift to the LHS, 4i2 minus i2 is 3i2, and this plus i1 is there. If I shift to left side, it is minus i1, and this 5 is there. I'm writing current parameters here and constant parameters outside. So plus 5 will become, this is plus 5. This plus 5 will become minus 5 if I shift to right side. I got that 3i2 minus i1 is equal to minus 5. And see this, which circuit it is? Parallel circuit. No resistors here. Is there any resistors like this? There are no resistors. If there are no
No,
resistors,
no.
okay, if there are no resistors,
No, sir.
it is that. Okay, if there are no resistor, whatever the voltage here, and this potential, all will be same. Okay, so I'm erasing this because no resistors are here. If resistors are there, again there will be drop will be taking place. Clear? If resistors will be there, the voltage will divide at that resistor. So because of there is no resistors, whatever the voltage is there, the same voltage, because in parallel voltage is same. Okay, the same voltage will be applied. Okay, so we know that Ohm's law. We know that Ohm's law. We here all I am considering this total node voltage as capital V. Okay, what is current? We know that Ohm's law V is equal to I
IR.
IR.
R into R. I is equal to
V
V
by
by
R.
R.
V. I is equal to V by R. That is V by R. In I1 branch, what is R? R is 1
1.
only, no?
Yes, sir.
1. And voltage is V. V by 1, that is V. In I2 branch,